In this section, we are using the transformation of a function. So we start from a basic function and we transform that basic function to get a graph of different function. Okay, so let's take a function. We have y equals to, so let's say our function is y equals to x square. Okay, sorry. So we have y equals to x square. So this is a square function. The shape of a graph is parabola. Okay. Now in this basic function, so this is our basic function. Now in this basic function, let's add some number. Okay. So we have y equals to x square, and we are adding some number. Okay. Let's say we are adding 5. What happens to the graph? Now when we add any number, okay, when we add any number to our function, see, our graph is shifted vertically up by 1, 2, 3, 4, 5 units. So adding a number to a function means we are shifting our graph vertically up by 5 units. Okay. Now let's see what happens if we subtract any number from that function. So we have a same function, y equals to x square, and from this function let's subtract 3. Okay, so if we subtract 3 from this basic function, our graph is shifted vertically down by 1, 2, 3 units. Okay, so adding a number means you are moving your graph vertically up. Subtracting a number from a function means you are moving your graph vertically down. Okay, so this is one type of transformation. And next we had, so if we replace x of a function, okay, so for this basic function, let's replace our x by x plus 3. So what happens? So instead of x, I will write down x plus 3, x plus 3, and we do have a square. Okay, so here instead of this x, we replace this x by x plus 3. Now when we replace x of a basic function by x plus some number, then what happened to our graph? So we had our basic graph here. It shifted on the left side by 1, 2, 3 units. Okay, so replacing x of a function by x plus some number means we are shifting our graph on the left side by whatever number you have here. Okay, if you replace by x plus 9, then you are moving your graph on the left 9 unit. Okay, in the similar way we had, so if we replace x of a function by x minus some number, let me take 5. Okay, so if we are replacing x of a function by x minus 5, then what happens to the graph? Our graph, this is the graph for a basic function. This graph is shifted on the right by 1, 2, 3, 4, 5 units. Okay, so replacing x of a function by x minus some number means we are moving our graph on the right side by 5 units. Okay, so these are the transformation that we had in our last class. Okay, now, so what happens? So if we multiply our function by a number which is greater than 1. Okay, so let me take a same function. So let me get rid of this. So let me take a same function. Okay, we have a y equals to x square. Okay, we have a square function. Now to this function, now let's multiply this function by a number which is greater than 1. Okay, so let's say we have y equals to, and we have a number greater than 1. So 5 times x square, 5x square. Now what's the difference here? So this is our basic function. We multiplied our basic function by a number which is greater than 1. Okay, so when we multiply our basic function by a number which is greater than 1, then our graph is stretched vertically towards the y-axis. Okay, so this is the graph for the red is the graph for our basic function. Okay, and the blue is the graph for this function which we multiply by a number greater than 1. Okay, so if this is the case, so if we are multiplying our basic function by a number greater than 1, then our graph is stretched vertically, you can say away from the x-axis or towards the x-axis. Now instead of that, what happens if we multiply by a number which is in between 0 and 1? So let's say we have y equals to, let's multiply by 0.5 x square. Now see the difference here. So here we multiplied by a number greater than 1. Here we multiplied by a number which is in between 0 and 1. Okay, so multiplying a graph with a number greater than 1 means, so if we multiply a number greater than 1 means the graph is stretched vertically away from the x-axis. Okay, and if we multiply by a number which is in between 0 and 1, the graph is compressed vertically towards the x-axis, and that's what we can see here. Okay, so this graph, so this is the red is the one where we started. When we multiply by 5, it's moving away from the x-axis. Okay, when we multiply by a number in between 0 and 1, it's towards the x-axis. So this is what we had. When we multiply by 0.5, this is the final graph. Okay, so multiplying by a number in between 0 and 1, that means we are compressing. Okay, the graph is compressed vertically towards the x-axis. So this is the vertical scaling. Okay, next here we have a function. Okay, and if we multiply our function by a negative, then the graph is reflected across the x-axis. Now let's see in the graph here. So we have a function. Okay, we have this basic function, and if you multiply this function by a negative, yes, I'm sorry? Oh, okay. Does anyone need a handout? Anyone else? So we have this function. Now let's multiply this function by negative. So what happens if we multiply this function by negative? What we get? We get y equals to negative x square. Now when we multiply our function by negative, then this graph is reflected across x-axis. You can just think of having mirror along the x-axis. Okay, so if we have a mirror along the x-axis, then this is the image we see on the mirror. Okay, so multiplying our function by a negative means we are reflecting the graph across x-axis. In a similar way, let me take a different function. For example, we have y equals to square root of x. Okay, so this is a new basic function. Now if we multiply this function by a negative, we get y equals to negative square root of x. So this is the reflection across the x-axis. So the graph gets reflected across the x-axis. So this is the case when we multiply our function by negative. Okay, so multiplying a function by a negative means we are reflecting our graph across the x-axis. So this is the next transformation. Okay, now here we have to identify the basic function, and then we use the transformation to sketch the graph of this function. So here we have g of x equals to 3 times square root of x. Now at first, what type of function is this? What is the basic function for this g of x? Is square root function, right? So our basic function, so let's write down basic function. So our basic function is y equals to square root of x. Okay, so let's draw our graph. Okay, and I will use the calculator to draw a graph here. So we already have the graph. So this is the graph for y equals to square root of x. Now from this basic function, how can we get g of x? What do we have to do? Do we have to add, subtract, replace, multiply? What do we have to do to this basic function to get 3 times square root of x? We have to multiply by 3. Now what does it mean by multiplying by 3? Now if we go back here, now here, whenever we multiply our function by a number greater than 1, so we use 3. So if we are multiplying our function by a number greater than 1, it means our graph is stretched vertically away from the x-axis. Okay, the graph gets stretched. So the graph is y equals to 3 times square root of x. See, the graph is stretched away from the x-axis. So this is the graph for a basic function. We multiplied by 3. Now the same graph goes away from the x-axis. So this is our x-axis. When we multiply by a number greater than 1, it goes away from the x-axis. Okay, so this is the vertical scaling. And on your exam, you can use your graphing calculator, okay? Or if you want, if you can use also like a table to graph, and if you have a calculator, you can use calculator and show this graph, okay? So this is the case when we multiply our function by a number greater than 1. Okay, the graph is vertically stretched away from the x-axis. Okay, now let's see the next one. Okay, so let me draw a final graph here. So this is the graph for our basic function y equals to square root of x. We multiplied, and multiplying means it goes away from the x-axis, and this is our g of x equals to 3 square root of x. Okay, at least you need to draw a graph for a basic function and the graph for a function given to you. So multiplying by a number greater than 1 means we are stretching our graph away from the x-axis. Okay, now let's do number B. So in number B, we have g of x equals to negative 2 absolute value of x. Now, at first, what is the basic function? What is the basic function? So let's find out the basic function here. Y equals to absolute value of x. So this is the basic function. Okay. Now, from this basic function, absolute value of x, we need to get negative 2 absolute value of x. Now, how can we get negative 2 absolute value of x from this absolute value of x? What do we need to do? We need to multiply by a negative number. Now, what does it mean by multiplying by a negative number? Now, if we go back here, so whenever we multiply our function by negative, our graph is reflected across the x-axis. Okay, and multiplying by a number which is by a 2 means we are stretching our graph vertically. Okay, so let me use a calculator. So let's start by drawing a graph of a basic function. So our basic function is y equals to absolute value of x. Okay, so this is our basic function. Now we need to get negative 2. At first, let's multiply by negative. Okay, so if we multiply this function by negative, we get negative absolute value of x. See, the graph is reflected across x-axis. Now we need 2, right? So multiplying by 2 means we stretch vertically away from the x-axis. So we have y equals to negative 2 absolute value of x. So this is the graph for a basic function. Okay, we multiplied by a negative. Multiplying by a negative means we are reflecting our graph across the x-axis. This is the graph we get, and we need a 2. So we are using a number greater than 1. It means this graph goes away from the x-axis. Okay, oh, this is x-axis, and it goes away from the x x-axis. Okay, so this is our final graph. So this black graph is a final graph for a function. Yes.
Will we start to graph the blue one first?
No, you can just, okay, instead of multiplying by negative first, you can multiply by 2. Okay, so you can do like this. So let's start from here. So let's multiply by, so let me erase this. Okay, so let's multiply our function by 2 first. So we have 2 times absolute value of x. Okay, now the graph is stretched vertically. Now let's multiply by negative. So we have negative 2 absolute value of x. Okay, so it's not wrong. So our final graph, this is the final graph, and this is what we need. We started from this basic from this green graph. Okay, we started from here. Okay, and this is our final graph, and you can use any transformation in any order. Okay, it does not matter. Okay, so let me draw the same graph here. So you have a question, Kendall? Okay, so here, so you do not need perfect graph here. Okay, so let's start with a basic function. So this is the graph. Make sure it has to be v shape. So this is our basic function, y equals to absolute value of x. Okay, now let's multiply by 2. Multiplying by 2 means you are stretching away from the x-axis. Okay, you make the v away from the x-axis. So this is y equals to 2 times absolute value of x. Now we need negative. Okay, so negative means we have to multiply by negative number. So that means you are reflecting that graph across the x-axis. So this is our g of x. So this is our g of x equals to negative 2 times absolute value of x. This is how we use the transformation to get this final graph. We started from a basic function, this red graph. Okay, we stretch this graph vertically away from the x-axis, then reflect it across the x-axis, and we get the graph for our g of x. Okay, any question up to here? Okay, now the next here we have a number c. So in number c we have a g of x. We need to graph g of x equals to negative 2x plus 1 plus 3. First step is identifying the basic function. So who can tell me a basic function for this g of x? Yes, so it's the same, y equals to absolute value of x. So y equals to absolute value of x is the basic function. Okay, now how can we get this expression? Okay, we have to get this expression from absolute value of x. Now what do we need to do? So what do you want to do at first? Do you want to add, or you want to subtract, multiply? What do you want to do?
Would subtract be the best?
I'm sorry?
Subtract.
Subtracting what?
The one side.
Now, if you subtract 1, mean we have absolute value of x minus 1. Now, do we have minus 1 here? We do not have. So, this does not help here. So, how can we get? Okay, so this is what you have. So, this is what you have, absolute value of x. From this absolute value of x, we need to get this expression by multiplying, adding, replacing. Okay, now, so let's multiply this absolute value of x by negative 2. So at first we multiply by, okay, let's multiply by negative. So multiply by negative 1, okay, or like negative. So if we multiply this by negative 1, we get y equals to negative absolute value of x. Now see, we had positive absolute value of x. We want to have this negative. So we multiplied this basic function by negative. Now what does it mean? So what happens if we multiply our basic function by negative? What is the transformation? How the graph react? It's reflected across x-axis, right? So we have reflection here across x-axis. Okay, we will see this in graph. Now this is what we have now. We have y equals to negative absolute value of x. Now what we need next? Our target is getting negative 2 absolute value x plus 1 plus 3. So what do we need to do next? We multiply by, we need 2 here, right? So let's multiply by 2. Multiply by 2. So if we multiply by 2 means we get y equals to negative as it is, and we have 2 absolute value of x. Now what does it mean by multiplying a function by a number greater than 1? What is the transformation? The graph is traced vertically away from the x-axis. Okay, so this is the graph is traced vertically. Okay, so multiplying a function by a number greater than 1 means we are stretching our graph vertically away from the x-axis. So we are almost there. Okay, we have negative 2 here, we have negative 2 here. Now instead of x, what we need? We need x plus 1. Now how do we get that x plus 1? What do we have to do? We have to replace. So we replace x, right? So we replace x of this function by this expression x plus 1. X plus 1. Now what does it mean to a graph? What happens to the graph if you replace x of a function by x plus 1? Where it goes? It shifts horizontally left by how many unit? 1, right? So shift left by 1 unit. Okay, now so our y becomes negative 2 absolute value x plus 1. Okay, we replace this x by x plus 1. So this is what we have. Now what we need at the end, see, so let's see. So we have this expression, we need plus 3. And how do we get that plus 3? By adding 3, right? So we add 3. Now adding 3 means we have y equals to negative 2 x plus 1 plus 3. Now what happens to the graph if we add 3? Up by how many unit? 3, right? Okay, so these are the transformation here. So we started from a basic function, we multiplied by negative 1. It means we reflect the graph of this function across x-axis. We stretch that graph vertically, we shift on the left by 1 unit, and we move that graph up by 3 unit. We get the final graph. Now let's see this all transformation in our graphing calculator. Okay, we can also draw here. Okay, so we know how to draw a graph for a basic function, right? So what will be a graph for a basic function? So our basic function is y equals to absolute value of x. So it's a V shape, right? We draw V shape at origin. So this is our basic function. So this is y equals to absolute value of x. Okay, now we multiplied the function by negative. It means we reflect that. Just imagine that you have a mirror along this x-axis. Okay, then we see the image, exact same graph, and it flips, right? So this is our y equals to negative absolute value of x. Then what we did next, we multiplied that graph, okay, by positive 2. So it means we stretch that graph away from the x-axis. So we stretch away from the x-axis. So this is our y equals to negative 2 absolute value of x. Now next we replace x by x plus 1. Now we shift this graph on the left by 1 unit. So this is 0 here. So this is negative 1. So we draw this red graph, okay, and just to draw V shape. Okay, So this is our y equals to -2 absolute value of x plus 1, and at the end we added 3. Adding 3 means you are moving your graph vertically up by 3 units. So 1 2 3. So let's move this point. Okay, so we are moving that point over here, and our final graph is, so this is our final graph, y equals to -2 absolute value x plus 1 plus 3. Okay, so this is how we can use, so this is where we started. Okay, and this is our final graph. So we use different transformation to get a graph of a given function from a basic function. Okay, and this transformation you do not need to memorize. Okay, it will be given on your formula sheet, but you should know how to use this. Okay, okay, any question up to here? And to graph you have to show all these steps. Okay, and you can use your graphing calculator to graph. Okay, if you are not sure, you can use your graphing calculator, but you are required to show all these details.
The written or the graph?
Both. Okay, so you will be asked to write down the transformation, and you will be asked to draw a graph for each transformation. Okay, any question up to here? Can I go to the next page? Okay, so the next here we have a horizontal scaling. Okay, so in horizontal scaling means if we replace x of a function by c times x. Okay, c is a number greater than 1. So we have a function and we replace x of that function by c times x. Our c is a number greater than 1. Okay, like if we replace our x by 2x, 3x, 5x, then the graph is compressed horizontally towards y-axis. Okay, let's see what does it mean on a graph here. Okay, so let me take y equals to our quadratic function x square. Okay, now if we replace x of this function, if we replace this x of this function by, let's say, 5x, so instead of x we write down 5x, and we have square as it is. Okay, so this is our basic function. We replace x of a basic function by c times x. C is a number greater than 1 here, so we replace by 5x. It means our graph is compressed. Okay, our graph is compressed horizontally. Okay, that's what it means here. So when we replace x of a function by c of x, the graph is compressed horizontally towards the y-axis. Okay, the graph goes towards the y-axis. Now instead of c greater than 1, what happens if we replace x by 0.5x? So instead of 5, let's replace by 0.5x. Now it is stretched horizontally. Okay, so when we replace x of a function by 0.5x, so 0.5 is a number in between 0 and 1. If that is the case, then our graph is stretched horizontally away from the y-axis. Okay, so this is our y-axis. If you replace x by a number which is greater than 1, okay, like a 4x, 2x, 3x, it goes towards the y-axis. Instead of c greater than 1, if you pick a number between 0 and 1, it goes away from the y-axis. Okay, so this is our horizontal scaling. So the next here we have, if we replace x of a function by negative x. Now we need to be able to find the difference here. Okay, so in here we multiplied our function by negative. When we multiply our function by negative, the graph is reflected across x-axis. Now we are replacing, not multiplying. Okay, so we have a x and we replace x of a function by negative x, then our graph is reflected across y-axis. Okay, so you can just imagine you have a mirror along the y-axis. That is a reflection across y-axis. Let's take an example. Okay, so let me take a different function here. So let's say we have y equals to square root of x. So this is a basic function. Now let's replace x of that function by negative x. So y equals to absolute square root negative x. You see that reflection across y-axis? So we had this y equals to square root of x. This is the graph here. What we did, we replaced x of a function. Instead of x, we replaced by negative x. It means the graph is reflected across y-axis. So you just imagine that you have a mirror here and you see the image here. Okay, so multiplying by, so if you multiply by negative, that's a different thing. Okay, multiplying by negative and replacing x is different thing. So if you multiply by negative, it is reflected across x-axis. This is the graph we get. If you replace x by negative x, this is the graph we get. Okay, and this transformation will be given to you. You do not need to memorize. Okay, so these are the transformation, and the most important transformation, it's okay if you skip this truth transformation. Okay, at least I want you to know that replacing x of a function by negative x means we are reflecting across y-axis. So this is what I want you to know, at least this one. You can ignore horizontal scaling. I want you to know multiplying a function by negative means we are reflecting across x-axis. I want you to know this one. You can ignore vertical scaling, and I want you to know horizontal shift, and I want you to know vertical shift. Okay, so 1, 2, 3, 4 transformation. Okay, at least I want you to know 4 transformation. Okay, you can skip horizontal scaling and vertical scaling. Okay, now we have more example here. So here we have to find a suitable expression for the function represented by the graph. Okay, so we have to find the equation here. We have to find what is the equation for this graph. Now at first, what is the shape of graph? It's a V shape, right? So V shape means what should be our basic function? Absolute value. So let's start by writing a basic function. So we start. Okay, this is not the final answer. So we start by writing the absolute value of x as a basic function. Now, the graph of this function is at origin, right? Now so let me draw that and see the difference here. So our graph for this basic function is this B shape, right? Now what difference is? Now how far is this graph from our basic function? It's on the left side by how many units? It's moving on the left by 1 unit, right? Now how do we move our graph on the left by 1 unit? What do we have to do? We have to replace x by x plus 1. So instead of x in this basic function, we write down y equals to absolute value of x plus 1. And this is our final answer. Okay, so at first we find the basic function. Okay, now from that basic function you have to check where that graph is moving. Now since the graph is on the left by 1 unit, So we replace x of a function by x plus 1. Okay, second graph. What is the basic function for this one? Y equals to x squared. Okay, so we have y equals to x squared. So this is a basic function, and the graph of that basic function is at origin. Okay, let me redraw this one. So this is the graph for a basic function. Now, how this graph is moving to here? So okay, so we have to find, okay, this point, the coordinate of this point is 1, -2. Now from here, we have to go here. So this is on the right side, right? So it's on the right side and it's going down. So there are two transformations. So moving, now how far we need to go on the right side? 1 unit, right? And how far we need to go down? 2. Now what does it mean by going on the right? So what does it mean moving on the right means? We are replacing x by x minus 1, and going down by 2 unit means -2. And this is the final answer. So even from the graph we can find what equation is that. Okay, I think you can do number 3 here. It's very similar. We have a same basic function, right? So let's find the coordinate of this point, which is -2, 1. So our graph for a basic function is, this is the graph for a basic function. Now we need to move here. So how do we move? We go left by 2 unit and go up by 1 unit. Now we have to write down that means. So moving left means we replace x by x plus 2. No, we are moving left by 2 unit. Okay, 1, 2. So it means we are replacing x by x plus 2. Instead of x, you write down x plus 2. And we are moving up, means you are adding 1. We are moving up by 1 unit means we are adding 1. Okay, any question up to here? Now, the next here, we have to write an equation. So we have the verbal description given to us, and we have to find algebraic expression for the function. So the graph of a function f of t is formed by translating this graph. So this is our basic function. So we are starting from basic function h of t equals to t square. Okay, so you are translating this graph to the right by 2 unit. Now what does that mean? So translating graph to the right by 2 unit means what will be our basic function looks like now? It will be, so moving right means replacing t by t minus 2. Okay, bless you. So instead of this t, we write down t minus 2 is square as it is, and upward by 6. What does it mean by upward? Means adding 6. So this is the final answer. So going right, left means you are replacing. Going up, down means you are adding or subtracting. Okay. Okay, the next here we have our basic function f of t equals to absolute value of t, and you are moving to the left 4 units. How do we move on the left by 4 units? What do we have to do? We replace t by what? T plus. Okay, it might be confusing, so replace, not parenthesis, had to be absolute value. Okay, left means t plus, right means t minus. Okay, and down by, so we move the same graph down 3 units. What does that mean? We subtract 3. So this is the final expression. Yes. The oh yeah, the final answer is it has given a name g of t. So yeah, you can just yeah. Then instead of f's, we have g of t. But it's okay. Okay, you can have any name here. That's not be a problem here. So since the final graph is g of t, and here final graph is f of t, so instead of h, let's write down f. But both of these are correct. Okay. So here key is the transformation. Okay, you do not need to memorize, but you should know how to use this transformation. And okay, we have a final graph. Now let me tell you, you will get a very similar question on your final exam. Okay, you might get on this next exam. Oh, we don't have a exam for this unit. I think we have a quiz, but you will get very similar question on your final exam. Okay, so this is for final exam. Do not expect exactly same graph. Okay, but you will be asked very similar question. Now here we have the graph f here. Okay, and we need to graph f of x plus 2. So we have f of x. Okay, so this is our f of x. From that f of x, we need to get f of x plus 2. What do we have to do to get f of x plus 2 from f of x? We add 2. Now what does that mean? Adding 2 means we are moving this graph up by 2 units. So we move each point up by 2 units and we get the graph of this function. Okay, so let me draw on that same here. So let's move this point up by 2 units. Where do we reach? So this is 5, this is 6. So 1, 2. So this is our first point. Okay, now let's move this point up by 2 units. 1, 2. So we have this point to 1, 2, this point 1, 2, this point. Now let's connect as like f of x. You just connect in the similar way, okay, as it's given. So this is the graph for f of x plus 2. You are moving every point, okay, every point by 2 units, and you get the graph for this function. If you want to draw in a next different new coordinate system, it's fine, but I will be using the same here. Now what we have next? Okay, next is a lot. So in next here we have, let me write down here. So we have part B, f of x plus 2 minus 1. Now how do we get this expression from f of x? How can we get? So we have f of x and we need to get this f of x. So we have negative here, right? We have instead of x, we have x plus 2 and we have a negative. Now, so how do we get negative? We multiply this function by negative, right? So what does that mean by multiplying by a function by negative? Are we reflecting across x-axis or a y-axis? X-axis. Okay, so at first, so let's write down that. So we reflect across x-axis. Now reflecting across x-axis means we are switching the y coordinate. If it's positive, we are making negative. If it's negative, we are making positive. Okay, so it means instead of y, we replace every y coordinate by negative y. Okay, reflecting across x-axis means we are replacing y by negative y. If we are reflecting across x-axis, so if we are reflecting across y-axis, it means replacing x by negative x. So for every coordinate, we change it negative y, we make it negative. Then next we need to get x plus 2. How do we get x plus 2? So we have to replace x by x plus 2 means what do we do to a point? replacing x, we are moving that point to the left by 2 unit. Now when we are moving a point on the left by 2 unit, which coordinate changes? Does y coordinate changes? Only x coordinate changes, right? So we are subtracting, okay, so moving left by 2 unit, and we need to get -1. -1 means we are moving down by 1 unit. Now can we do all these 3 transformation for each point? So we have 4 points. Let's do that. Okay, so let me start from this point. The coordinate of this point is -3, 4. Now if we reflect across x-axis, what will be coordinate for that point? So we have -3, 4. We are reflecting this point across x-axis. It means you switch the sign of y coordinate. What would be the point? -3, -4. Now you are moving that point on the left by 2 unit. Can you? Okay, so reflecting, okay, let me do each point. Okay, so we have this point, reflecting this point across x-axis means, just think you have a mirror here. Where do we see this point? We will see this point here, right? We will see here. Now you move this point left by 2 unit, 1, 2, then you go down by 1 unit. So this is our final point. Any question? So now in a similar way, let's move this point. At first, let's reflect this across x-axis. So where do we see this point if we have a mirror along the x-axis? At the same point, right? Now you go left 2 unit, sorry. So you go left 2 unit, 1, 2. Then you go down 1 unit. So we have this final point. Okay, so this is our final point. Now let's do the same thing for this point. At first, you imagine you have a mirror here. So we see this point over here, and you move left by 2 unit, 1, 2 unit, and go down 1 unit. So this is our final point. Last point, we have this point. Reflect this point. So if you have a mirror here, we see this point over here, right? So we see there. Then we move that point on the left by 2 unit, 1, 2, then go down by 1 unit, 1. Now let's connect all these dots. So these two, this and this. So this is a final graph for this function. So this is our negative f of x plus 2 minus 1. Okay.